everybody, get ready to do Pre-Algebra Math 4.5, Part 1. 4.5 Rules of Exponents. We have a 38-point skill sheet today. We have no note-taking today for this section. Teachers, here's today's bell work. Find an LCM of these monomials. Ditto for down here. Give your students 5 minutes for this. Okay, welcome back for our solutions to our bell work today. Here's 60s to the 4th power factored out, and then 24s cubed factored out. So the LCM would be 2 times 2 times 3 times s cubed times 2 times 5 times s. So it'll be 120s to the 4th power here. Both of those numbers will go into 120s to the 4th. So that would be your LCM of these up here. 24 will go into that 5s, and then 60s to the 4th go into that twice. So that would be the LCM of these two expressions here. And then for down here for number 2, same thing here. We have 5 times 5 times a for the factoring up here. Then we have 5 times a for 40a squared here. We share these factors here. So we know our multiple will have to be have an a squared to it. So which one of these will be the least LCM of 25 and 40? It'd be 5 times a times 2 times 2 times 2 times 5, 2 times 2 times 2 times 5 times a here. So it'll be 200a squared. So the LCM of 25a and 40a squared will be 200a squared. Both of these numbers will factor into 200a squared. That would be the least common multiple. Okay, into our lesson today, you evaluated powers. You will multiply and divide. So what we have here is, notice what happens when you multiply two powers with the same base. So we have a to the 4th times a to a cubed. So here's a to the 4th, here's a cubed. We just add. We add our exponents here. So this quantity here would be a to the 7th. We have 7 factors of a. This example suggests a rule for multiplying powers with the same base. So classwork page 3. Multiply powers same base, add their exponents. So a to the m to a to the nth will be a to the m plus n. Then here's an example here of numbers. 4 cubed times 4 squared will be 4 to the 5th. We just add exponents. Okay, we're going to go to the example 2. We're going to jump right to example 2. Example 1 is available in one of the other sections. What do we do? What do we have here? X to the 6th times x to the 9th. We just add our exponents up here. We have same base, or same base here is x, so we use a product of powers. And we get x to the 15th. In this situation here, we have 3x times 5x to the 5th. What do we do with that? We have 3 times 5 times x to the 1st power times x to the 5th. Commutative property of multiplication. And so now what we need to do, we have 3 times 5 taken care of. We need to take care of our powers here. So we add our powers, 1 plus 5. So this will be broken down. 3 times 5 times x to the 6th, which would be 15x to the 6th, would be the product of those two quantities. Find the product or quotient. Write your answer using exponents. Students, this is yours down here. So let's do our guided practice here. Here's the solution here. 2 times 7 times m to the 4th times n to the 5th. They both have the same base. So we add our exponents here. We multiply 2 times 7, be 14m to the 4 plus 5, which would equal 9. Students, this is yours. You should be able to do that on your. And let's get into another concept slide here, quotient of powers. This is a related rule you can use for dividing powers of the same base. We have a to the 5th over a squared. This will be broken down here, what it would look like. So these will cancel here. You have 2 of these a's will cancel. What are we left up there? We're left with a times a times a. So that would be a to the 5 minus 2, would it not? I mean, this is the same amount of a's that you have left in your numerator, a to the 5 minus 2, which equals a cubed. And this is the general idea of the quotient property of power. So to divide power of the same base, subtract the exponent of the denominator from the exponent of the numerator. So this situation here where you have a to the m minus n, where a cannot equal 0, of course. So the numbers, so 6 to the 8 minus 5, so this would be 6 cubed here, just using your quotient of property. Let's get into another example here using the quotient of powers. 7 to the 6 minus 2. What would that equal? That would be 7 to the 4th power. And then for b here, 4x to the 8th over 10x to the squared. So it'd be 4x to the 8 minus 2, because here's your same base here. The 10 would stay down in the denominator, and you'd simplify further. 4x to the 6 over 10, and even further, 2x to the 6 over 5. We would cancel out, we factor out 2 out of numerator and denominator, and that would be your quotient there. Find your product quotient, write your answer using exponents. We're going to do that. Students, this is yours here. Pay attention so you can do your independent practice. Okay, so this would be our solution up here, 12n to the 5 minus 2. These two have the same base, so we subtract 5 minus 2. The 8 stays down in the denominator, and we further factor out a 4 here, so 3n cubed over 2 would be the simplified version of this quotient here. And that would do it for lesson 4.5, part 1. Part 2, part 3 available here, as well as worksheets, quizzes, and tests. Thank you.